Alright, so this video is going to be about the rational root theorem. And the rational root theorem does not actually find polynomials or zeros of a polynomial for you. What it does is it actually just helps you find possible rational zeros. So the thing that we all need to understand is that if f of x is a polynomial, right, then what we need to understand, then the zeros can fall under three categories. Can be, if they're real, they're rational, right? Or irrational if they're real zeros. So by real zeros we mean actual x-intercepts on a graph. Or polynomials can have zeros that are imaginary. So the rational root theorem, all this does right here, all that does is tell you if, or it tells you the possible rational zeros. It doesn't tell you anything about irrational if it has it, and it doesn't tell you anything about imaginary if it has it. And it doesn't guarantee that it has rational zeros. So why even use this? It's really just for when you don't have a calculator. So if you didn't have a calculator and you're stuck having to find zeros on your own, and you weren't given any, then this would be the way to start at least. Might not get you any results, but it can at least help. So let's start it off with, say, in our first example, let's say list. Example 1, list the possible rational zeros. So if you want the exact definition, go read your textbook. But if you just want the simple kind of explanation of what the rational root theorem is, then here you go. Let's say f of x equals 4x cubed minus 6x squared minus 12x minus 4. And that's the function. So it's cubic polynomial, and if you had to maybe find zeros, you'd try to factor it, but then you'd find out that it's not factorable by grouping, and so now you're stuck. So the rational root theorem helps you kind of get a jump start. So the way the rational root theorem works is you take the last number, the constant, and you take the leading coefficient. So the constant, I probably should have picked a different example. They're the same number, but it's alright. It'll still work. The constant is 4, and the leading coefficient is also 4. And what I want you to do is I want you to tell me all the factors of 4. So if you're not sure what I mean by factors of 4, I mean just start listing out the things that multiply to 4. So two numbers that multiply to 4 are 1 and 4. And then the other things that multiply to 4 are 2 and 2. But we're not going to write 2 twice. So the factors of 4 are 1, 2, and 4. And so those would be the same here. Here's how it's going to go, is we're going to divide all the top factors. We're going to divide the top factors by each factor on the denominator. So I'm going to go real slow and probably do extra work that once you get the hang of it you won't do, but hopefully it'll make sense. So the top factors are 1, 2, and 4. So first I'm going to divide 1, 2, and 4 by 1. And so I would get 1 divided by 1, which is 1. I'm going to get 2 divided by 1, which is 2, and obviously 4 divided by 1, which is 4. So what this says is the possible zeros, the rational root theorem said, can be 1, 2, or 4, but also their opposites. So plus or minus 1, plus or minus 2, plus or minus 4 potentially could be zeros of that polynomial. And then you just kind of keep doing it. So if I were If I could erase faster. So now I'm going to just kind of do the next thing here. I'm going to take now 1, and I'm going to take 1, 2, and 4, and I'm going to divide them now by 2. And so we're going to take 1 over 2, which is 1/2. And then we're going to take 2 over 2, which is 1, and 4 over 2, which is 2. So if you notice in my list already, I already have 1, and I already have 2. I'm not going to write them twice. But I don't have 1/2, so I'm going to say plus or minus 1/2. And then I'm going to do this one more time with 4. So 1 divided by 4 is 1/4. That would be new, plus or minus 1/4. 2 divided by 4 is 1/2. And so I already have that. And 4 divided by 4 is 1. I already have that. So these are my possible zeros. So then the question is how do you know if any of the possible zeros, how do you know if they are actually zeros of f of x? The easiest way to do it is to use synthetic division and see if it makes your remainder 0. So we'll just test one just in case you're asked to test it. So there's f of x, and if I wanted to, on the count of 3, let's both pick a number. 1, 2, 3, 4. Okay, so 4 is the number that I'm picking. So 4, if I want to know if 4 is a 0, right? Is 4 a 0? That's the question we're asking. So I take 4, put it on the outside of the synthetic division box, put 4, -6, -12, and -4. And then you just go off to the races. 4, that'd be 16, 10, that'd be 40, that'd be 28. That does not look like it's going to multiply. 4 times 48 is not going to multiply to 4 and be the opposite to add down, but we'll do it anyways. 2 carry the 3, 8, plus 3 is 11, so 112. Which would make 108. That needs to be 0. So if you're dying to know which one might work, you guessed it, it's going to be one of the fractions. So I'll just show you. -1/2. Put it in. Got 4, -6, -12, -4. And so bring the 4 down. And then you get -2. That'd be -8, and then you get 4, then you get -8, then you get 4, and then you get 0. And so if you had to, you could keep factoring or try to factor or solve using that, but we know that -1/2 is a 0. But all the rational root theorem does is it will find you a possible list, a list of possible zeros for f of x. The sad part is it could actually work out to where none of them work. And so that means all the zeros are either irrational or imaginary. So let's try one more and just kind of see the full picture of what you can do here when your teacher's nice to you and gives you a good problem that works real nicely. So here's what we'll say is we're going to say find all zeros. Okay, so this process without a calculator could potentially take a long time, because what if you just keep picking 0 after 0 that doesn't work? You'll feel super defeated, probably close your textbook, and then just quit that assignment. But not us, not today. I'll help you out. So here we go. G of x, okay, G of x equals 2x cubed minus 17x squared plus 12x plus 63. So we're going to take 63, which is our constant term, and we're going to list its factors. So what multiplies to 63? 1 and 63. What else? 3 and 21. And hopefully you said 7 and 9. And so those things multiply to 63. Then we're going to take 2, right? What multiplies to 2? I guess 1 and 2. So now we're going to divide all the factors on the numerator. We're going to divide all of those by each factor on the denominator. So 1 over 1, right, is basically all of the ones on top divided. My possibilities, possible zeros, are just going to be all of those integers. So plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 9, plus or minus 21, and plus or minus 63. And then I'm going to divide them all by 2. So now it's plus or minus 1/2, plus or minus 3/2, plus or minus, you guessed it, 7/2, plus or minus 9/2, plus or minus 21/2, and plus or minus 63/2. Now if you actually have to find the zeros, you just start guessing. And you start picking numbers, right? So testing them. So if you have a favorite number in this list, pick it. If your favorite number is mine, then let's say it together on the count of 3. 1, 2, 3, 7. Yes, everybody loves the number 7. So let's test it. 2, negative 17, 12, and 63. Excuse me. So if it works, it'll end in a 0. So here we go. 2, 14, negative 3, negative 21. Oh goodness, do it right. That'd be negative 9. Oh, winner, winner. Look at that. Negative 63. That's a 0. So let's factor g of x real quick. G of x, we divided by 7, but really that's x minus 7. And then 2x squared minus 3x minus 9. And if I have to find more zeros of that function, now it's a quadratic, and hopefully I can either use the quadratic formula, or it factors, or complete the square. Let's try to factor it. 2x, x, and we want it to multiply to negative 9, but add to negative 3. So I think I want this to be minus 3, and I want this to be plus 3. That would multiply to negative 9, but then give me negative 6 plus 3x, and that'd be negative 3x. So that works. So there's g of x. We got lucky, not really. I knew it was going to do that. So, but yes, this is your list of possible zeros. And sometimes it's like searching for a needle in a haystack if your teacher's super mean and says, okay, good luck. But sometimes they'll give you a hint, or they'll let you use a calculator to help you find one, and then you can show them that you can find the rest using division, factoring, or some other method of solving. So the zeros would be 7, negative 3/2, and 3. And actually all of those are in our list. So, all right, have a great day.